Alright, how you guys doing today? This is Mr. Muscarella coming at you, and we're going to take a look at finding a trig function given another trig function. So here we have this problem. Suppose cosecant of theta equals -2 and the terminal side of the angle lies in quadrant 3. Find tangent of theta. So I'm going to first take a look at this piece of information. Cosecant of theta equals -2. The second piece of information that I'm told is that our angle, theta, is going to lie in quadrant number 3. So I'm going to just kind of draw a sketch of that. And I know my angle is going to be somewhere here in quadrant 3. So since my angle is there, I'm going to go ahead and draw a triangle there in quadrant number 3. Next, I'm going to go back and analyze cosecant of theta. So cosecant of theta is -2. Now, if you remember your geometry days, cosecant and sine are reciprocal functions. So that means that the sine of theta, my angle, if it's the reciprocal function, then I just take the reciprocal of -2, which is -1/2. Now, also from our geometry days, what you want to do is kind of remember that sine is the ratio of opposite over hypotenuse. So if it's opposite over hypotenuse, then I'm going to go ahead and take a look at my triangle that I drew in quadrant number 3. Now the opposite of where theta is -1, and my hypotenuse is 2. Now sometimes people will get the sign mixed up, and the way that you can tell that is where the -1 is in this case, that is along the y-axis. So when you take a look at that, in quadrant number 3, that y-coordinate is always going to be negative. Now the hypotenuse, which in this case is 2, that represents your radius, and your radius of any triangle is always going to be a positive value. Now next what we're going to do is we're going to just use trigonometry and an old theorem called the Pythagorean theorem to find this missing side right here. And I'm just going to call this x. So to find the missing side, we're going to go ahead and use the Pythagorean theorem to find that. So I'm going to have 2 squared equals -1 squared plus x squared. 2 squared is 4, and of course -1 squared is 1 plus x squared. When you subtract 1, you end up with 3 for the value of x squared, and then you have to do plus or minus, and don't forget that piece, so plus or minus a square root of 3. That's going to be our value of x. Now, to figure out which one it is, because I have 2 answers, one is square root of 3 and the other is -square root of 3, and only one of those is our answer here. So based on the location of where the x is here in quadrant 2 or quadrant 3, my x is always going to be negative. So that means this is going to be the -square root of 3 for that value. Now, what I'm asked to find is tangent. So tangent of theta, remember, from geometry days, tangent is going to be adjacent over opposite. Oops, wait, no, that's cotangent. See, I'm thinking of reciprocal functions here. Tangent, of course, is going to be opposite over adjacent. So now that I know all 3 sides of my right triangle, I simply just go ahead and fill in the value that I need for tangent of theta. And tangent, the opposite side of theta, is -1. And my adjacent side is -square root of 3. Now I do have to simplify this because I have a square root in the denominator, as well as both the numerator and the denominator are negatives. So tangent of theta is going to be 1 over square root of 3, but then when we rationalize, remember you multiply by square root of 3 over square root of 3. So when you're done simplifying that, you would end up with square root of 3 over 3 for the value of theta. And let's just do another thing kind of real quickly to check. I know some teachers will talk about this. They'll kind of make a graph like this, ASTC, and there's a lot of different ways people will remember that. Some are all students take calculus, but tangent is here in quadrant 3, which is where our triangle is drawn. So that checks out because tangent is going to be positive in quadrant 3, which is the type of answer that we ended up here. So that's it for this video. Thanks for watching, and I'll see you guys later. Peace out.